Okay, if you notice in your notes, I tell you that you do not, this is important, you do not need to do the evaluation of the integrals. You can use your calculator and check your answer for this entire assignment. Now, is there benefit to doing it by hand?
Yes.
Yes. Can they all be done by hand?
Yes.
Yes. So I would recommend that you do them by hand, but if you get bogged down for time, you can just use your calculator. Most importantly, I want you to be able to set up the integrals in this section.
Yes.
Okay? All right, so that is the disk method. Washer method.
So for washer disk, you can use like it's like the same thing, same type of problems, right? The disk and washer.
Yeah. Okay, for, what do you mean same type?
Like you can like if you have a problem, you can use either or of the equations.
No.
Okay.
Okay, so this is a scenario where the disk method does not work because we're going to revolve this around the x-axis again. So if I revolve this shape around the x-axis, what kind of solid am I going to form?
Like a bowl.
If we did that, it'd be...
It'll be like a bowl.
It'd be like
Like a bowl.
it's like a UFO.
Bowl.
Oops. One of these got to be straight. So can you kind of see it?
It's a butterfly.
All right, so when do you use the washer method? You use the washer method when it's going to be hollow in the middle. Disk method is always going to be completely solid. Does that make sense? There's a gap here. You can see that if you revolve it, you're going to be able to hold water. There's a hole inside of it. Okay, but you could just do the disk method twice. You could find that. If I revolve just this line around, the area underneath the round, we're going to have our cone again, right? And then you could just subtract this parabola, you know, the stuff inside where the water is. If you do that one minus this one, you get the washer method. You're basically doing the disk method twice. Okay? So if you look at the...
Yeah, but if you just spin one of the, there you go. If you just spin one.
If you look at a cross section, it's not a circle like we had before. It's a small circle inside a big circle. That's where the washer comes. Okay? So if you did the large circle minus the smaller circle, and you factored out a pi, that's our formula. Pi times big R squared minus little r squared. R, capital R represents the outer radius. Little r is the small radius. Okay? So in this case, it is the integral. Are we integrating with respect to x or y? X. Disk and washer are very similar. If it's revolving around a horizontal axis, it's going to be x. Okay, and it's pi times... What's my outer r?
2x.
2y.
2x.
2 something.
Yeah. 2x.
What's my inner x?
X squared.
1x.
X squared.
Okay, there's my big R, there's my little r, pi times big R squared minus little r squared, dx from where to where?
Wherever we want. Doesn't specify.
It doesn't, so we need to find out, we're going from 0 to something.
You need to set them equal to each other.
Good, set them equal to each other and solve for x. Okay, so they intercept at 0 and 2. So this point right there must be 2 comma something, so it is from 0 to 2.
2 comma something. Maybe 4.
Okay, questions so far?
Never know. Maybe 4.
Well, I'm going to add some more dynamite to it. Because we have not revolved around a vertical axis revolution yet. So let's take, that's why this is my last example.
My brain, the voices in your head are screaming.
All right, do you want a, I'll just do it myself.
I do too. Yes, part of
Voices in my head are dead.
30 seconds.
Playing on the battlefield.
30 seconds
All right, let's revolve this shape bounded by x equals 0, y equals 2, and y equals 1/3 x around the y-axis. Okay? Is this going to be a disc or washer?
Disc.
How do I know it's disc?
Because
It's not hollow.
Can't hold water.
It's not hollow. Very good.
Hold water.
Okay, so if I revolve this around, I'm going to get myself
Yeah, that's right. I said it's
We're taking this distance on
a cone, right?
Can't hold water.
Are we integrating with respect to x or y?
Why?
Why sizzle? Why is it why?
Yeah, why?
Because, honestly, because it's a vertical axis.
Why? Really?
Well, he said why, and he's just going like this. Didn't know if he was serious or not.
So, 3y, what up?
Hey, so it's pi r squared. What is my r?
3y.
Hang on, I got this.
2y.
3y.
2,
What is this distance right there?
3y.
1/3 x.
3y.
1/3
Okay, why do we gotta guess, guys?
Okay, we
Think
gotta
about
pick
this
it.
logically.
Okay, so y Lincoln.
Because we solved for
X is equal to 3y. If we're going to integrate with respect to y, our expression has to be in terms of y. That is x right there. And what is x equal to? 3y.
That's right when I said 2x.
Yay. Okay, what are my boundaries of integration?
So set them
Y equals 0 to y equals 2.
Remember, do we need to know this point right here?
Yeah.
kinda, sorta.
Got it
Oh,
all.
to an up and down.
No, we don't.
Why? It's bottom to top.
So it's 0 to 2.
Very good. You're right, Brenton. I'll give you credit for it.
26. There's your
Okay, there's your volume. What if I revolved it around the x-axis?
Washer.
Try it. See if you can set up an integral. See if you can set up an integral to find the volume of the green thing revolved around the x-axis. Go.
I read back.
Mr. Winslow.
Your mom's listening. Is that my son or daughter talking in your class?